All right, welcome everybody. So in this video, we are going to continue working with a model that we've constructed that uses data that we've observed about the literacy rate and GDP per capita from a small subset of countries to construct a linear model that's going to predict the GDP per capita of a country based on the observed literacy rate. And we set up a linear model of the form y is equal to beta 0 plus beta 1 times x1, which in this case is the literacy rate. And we found that the value for beta 0 and beta 1 that best fit this data would be beta 0 is approximately minus 1.938, and beta 1 is approximately 0.126. And so we can see that picture plotted over here. So my sample had 4 values. These are the 4 dots that we can see. And this was the model plotted, this line right here, that was the best fit to that. And that is based on the fact that we're minimizing the sum of all of the error terms squared. So solving that problem is the least squares problem, and that's how we derive this solution. And so now we can ask ourselves, great, what are the types of things that we do with models? And so there are really 2 important things to observe at this point, and that is we use models to make predictions. So for example, maybe there is another data point. So the United States was not included in these 4 data points. So let's say I happen to know that the literacy rate in the United States in 2020 was just under 80%. So we can round that up to 80%. And so based on the model that we've constructed above, I don't know, for example, what the GDP per capita of the US is, hypothetically. And so based on their literacy rate being 80%, what is the prediction for the GDP per capita of the US? And so we can just plug in the value that we've observed for the education level, for the literacy rate into this formula and simplify. And so this solution is given on the Google Colab notebook, which is linked below. And you can also find how we derived the solution to this problem in that Google Colab notebook. But I take my minus 1.938 plus 0.126 times 80, that's this literacy rate, and I get 8.163. So this is telling me that if a country's literacy rate is about 80%, then their prediction for their GDP per capita is about 8. And this means that their GDP per capita is predicted to be $8,163, for example. And we can compare this to the actual value for the GDP per capita for the US, which was actually 69,734. So this would not have been a good estimate for the United States. They would be more like way up here. And so at this point, we might be a little suspicious. Maybe we don't have the best model, but recall we just used a really small sample here. So we would probably want to use a larger sample, and then we can ask, maybe we should include other variables if this individual variable is not doing the best job at predicting the wealth, the GDP per capita. So yes, we can make predictions with these models. That's one really powerful thing that we do. Secondly, it tells us something more generally about the relationship between these variables. So question 2 is asking us to interpret the practical meaning of the slope and the vertical intercept of this linear model. So let's first consider the slope. Okay, and so the slope here is approximately 0.126. So on the one hand, I can see that this line goes up. So the fact that the slope is positive tells me there's a positive association, namely that as the literacy rate goes up, we seem to be observing that the GDP per capita of a country also tends to go up, though there are exceptions to these rules. So for example, here's a country whose literacy rate was 80%, and their GDP per capita was actually more than this country over here, whose literacy rate was a little bit bigger. So we're not saying that it's always a positive relationship, but overall, on average, as the literacy rate goes up, we're seeing that the wealth, the GDP per capita, also tends to go up. But I want to interpret this value in practical terms. So if I were to tell a colleague who is not very well versed in statistics or math in general that this tells us the slope of the line is 0.126, that might not be too helpful for them. So let's explain this in terms of literacy rates and GDP per capita in terms that they would understand. So what this model is telling me, the slope tells us every time we increase the input by 1 unit, approximately how much is the response variable predicted to change. So in this case, increasing the input by 1 unit means increasing the literacy rate by 1%. So this slope is saying when we increase the literacy rate by 1%, the GDP per capita is predicted to increase by $126 on average. So this 0.126 has units thousands of dollars per capita. So I want to convert this maybe into individual dollars. So that gives us really good information in general if I want to know if I increase my literacy rate by a certain number of percentage points, about how much should I predict that the wealth of this country is going to increase. Okay, next, let's interpret the vertical intercept of this formula of this model, which was minus 1.938. So visually, that tells us where our linear model, the graph of our linear model, happens to be crossing the vertical axis. And this is happening at a negative value, right? So we're below 0. And so if I want to interpret this technically, we can say it's giving us a prediction of the response when the predictor is equal to 0. So in this case, we're saying if a country's literacy rate was equal to 0, then this is telling me what their predicted GDP per capita would be. So if their literacy rate is 0%, then the predicted GDP per capita is going to be negative $1,938 approximately. And so in this case, what does it mean to have negative GDP per capita? Probably not much. And so what does it mean for the literacy rate of a country to be 0%? Well, luckily, there are no countries that have a literacy rate so low. So here's a situation where we're trying to use our model, which was based on predictor values that were at least 30 or above, to make a prediction about the response variable when the predictor variable is 0, okay, meaning that this is far removed from all of our observed values. So we probably don't want to use our model, which was based on countries that had literacy rates much bigger than 0, to make a prediction about a hypothetical country whose literacy rate is so far removed from all of our observed data. So in this case, the vertical intercept, we can try and interpret it, but it probably doesn't make any sense in this context. And that's fine. So usually it's the slopes that mean a little bit more to us than the intercepts. But certainly there are situations where it's reasonable to consider the response variable being 0, and therefore the vertical intercept does have some meaningful practical interpretation.